Hey guys, my name is Jonathan Harris and welcome to episode 3 of the Robotic Arm Project. I know that last week I said I wanted to work on the wrist and claw of the robot, but I had a lot of people grace me with their glorious and wonderful knowledge. Thanks to them, my small brain now knows what a freaking slip ring is. For those of you who are left in the dark about this great technology, a slip ring is an electromagnetical device that allows the transmission of electrical signals from a stationary to rotating structure. So basically what I gather from this is I can replace the cords in the shoulder of my robot with a slip ring, so that way I can actually have continuous rotation and not break the cables. At this point, I should probably know that if I have a stupid problem like this, there's obviously going to be a solution for it. Like, I shouldn't think, oh hey, I have a problem. No one's ever thought of this before. So I'm just gonna go ahead and install this slip ring before I start working on the wrist and claw. But I do hope to work on the wrist and claw in this episode. Okay, so I just reprinted the stationary rotation plate, so now that the slip ring actually fits into... So now the slip ring fits into the gear like this, and on the other side, we're going to use a piece of pipe that slots in, fits into this pipe. We're gonna glue it in. Then we're gonna add the rotation plate that the rest of the robot is on top of that. This will allow us to still have the cords coming through the middle, but then to stop this from coming up, we're gonna slip this little ring that I 3D printed on top of there, stopping it all from coming up. Okay, so now that we know what we're going to do, let's go ahead and put it all together. Okay, so now that I actually have continuous rotation, we can move on to the next part of the build. All right, that's enough talking, so let's hop into Fusion 360 and finish and make this wrist design. Okay, so the good thing about the wrist and claw is that we don't need to have gear reductions. So the wrist, the servo should be plenty powerful just to actuate the wrist, so we don't need a gear reduction, so we won't have to worry about that. We're basically just going to be having to make fancy servo brackets. The only real challenge here is going to be getting all the servos to fit together in a way that is compact but still has the needed functionality. Okay, so what I mean when I'm talking about like making the design compact is like technically this design right here would work, right? I mean, you could make it like this, all the parts would rotate how they need to, everything wouldn't be in the way, but it just kind of looks like a confused snake, to be honest. Like, I mean, it gives the needed movement, but just no, it doesn't work. Now this I like. All the pieces fold together in a specific way when I still get the functionality. See, the pivot comes up through here, connects right there. This servo is in here and connects right here. This can rotate all the way around, and it gives me all the functionality needed. Now, you'll notice that I don't have the actual claw itself modeled. That's because I want to do a separate video over that later where I actually make the claw modular. So that means I'll have multiple different claw designs that can be easily detached and reattached. So I can have multiple different claws for multiple different purposes. Alright, so now that those are printed out, I'm going to modify another batch of servos to allow for continuous rotation. I think I'm only going to have to modify at least one of them for the very bottom one. The other two don't need more than 180 degrees of freedom, so I think I can just slap in a regular servo. Ever since I talked about modifying servos in my first video, I've gotten progressively better and faster at doing it, so I think I'm going to make a separate tutorial over that later. To connect these little brackets, I'm just going to be using the little plastic pieces that come in the... Anyways, they should be plenty strong, and if they're not, I can just come back later and replace them. Worry about it later, but I think they're plenty strong. I've done a lot of robots in the past for like competitions and stuff where I use these, and it works just fine. So a thing that I like to do to make sure it's perfectly lined up is drill a bit into the table. And so that way I can line them both up around it. That way I know I'm perfectly centered and drill my holes from there. Like that. Now, you'll probably notice that I don't actually use screw holes for these servo mounts. Because number one, I honestly think pressure fit is gonna be enough for like small loads, and I'm just testing it right now. I'm not actually gonna glue it in until I know that it's working. But as you can see, I just put the little threads in there and cut the ends off in the excess. So I'm just gonna stick those on real quick. I've been thinking a lot about how I'm going to make the like motion detection, like actually knowing where it is at any point. Like how is this joint here going to know how far it's rotated at any point? And I have a couple of different things that I'm going to do for a couple of different joints. Now obviously these ones here at the top won't need it because they're just regular servos and haven't been adjusted. So everything still works. The potentiometer is still good on the inside. And so I don't have to worry about that. Now, but down here, on this joint, the big shoulder, I'm probably gonna use a click sensor somewhere around here or in the back right here. I am going to probably add an encoder for the base, but all the rest of these will be like little tactile digital switches that the arm can run into and click. I use a lot of those for when I'm running ball competitions because we have to use motors a lot in the place of servos, and it's just nice to have them around when you need them. All right, so I'm gonna do a lot more testing off camera. I'll go through, make sure everything works, servos are good, positions are good, and then once I do that, I'll glue it in, zip tie it, do all that. As you can see, I still don't have the claw on. I've told you I'm gonna make that modular. All right, well that's gonna be it for this video. If you have any comments or like advice that I could have, I'd love to hear it. Just leave it down in the comment section or on Reddit. I'll promise I read through all of them. I really appreciate it. If you want to go see the previous episodes, I'll leave a link in the description, and you can also go see like the intro to this channel where I basically talk about why I'm doing this. And I think next week we're gonna work on actually adding like digital sensors at the brakes of all the points, so it'll actually know where it is and have a little bit of sense of direction almost. Up here I obviously won't have to have those because these are just regular servos. There's nothing wrong with them. They have their positions in place, but on these down here I'll need to add click sensors like right here and things like that. All right, anyways, thanks for watching. See you next time.